He's late for math class. Hurry up, Conrad. He looks up at the tower with an angle of elevation of 12 degrees, and he sees Mrs. Braytek telling him, hurry up. So first, let's make sure we get the ground. And here's Conrad. Should we draw him running? Woo! Okay, he's kind of funny looking. And we're going to put Mrs. Braytek where? On the top of a tower. Okay, so let's put her up here. Okay. When he looks up, the angle of elevation is 12 degrees. So let's do looking up, angle of elevation, 12 degrees. Okay. He runs 20 feet closer. So he used to be here, and he runs 20 feet. 20 feet. So now he's standing here. And he sights an impatient Mrs. Braytek with an angle of elevation 35 degrees. So when you look up to here, this angle has changed to 35 degrees. Okay, this is a right triangle because the tower, of course, is nice and straight. Find the height of the tower. Okay, so the tower I'm going to call H because that's what we're trying to find. Let's make sure I'm happy up here. There we go. I'm going to put some other letters on this triangle here. I'm going to put an X, and let's make this part here be Y. Okay. I'm going to find some other angles here just to make sure that the problem is as easy as possible. These two angles right here form a straight line, so let's find the measure of this obtuse angle right there. 180 minus 35 is 145. Okay. How about the sum of the angles in this obtuse triangle? Can you tell me this angle way up here, this skinny one? 23 degrees. How about the one right here by the vertical? That angle right there is in a triangle, so that would be 55 degrees. Okay, now I know that we're trying to find H, and the only number for the side I've been given is 20. So I can't really look at this entire big triangle. I'm going to have to do some calculation here with the triangle that has the 20. Is there any relationship between this obtuse triangle and this right triangle? What do they share in common? So I think we're going to have to find Y. So let's look at this obtuse triangle. Can I do the law of sines? Sine of 23 degrees goes with what? Side 20. Okay. Now I'm trying to find Y, and that is across from 12. So that equals sine of 12 degrees over Y. Okay, so let's go ahead and cross multiply here. Y times the sine of 23 equals 20 times the sine of 12. Okay, try to not pick up your calculator just yet. Okay, we don't need those chopped off decimals because I don't want to be tempted with using a rounded number. Okay, Y is that stuff right there. Okay, just hang on to that. Now let's go back to the triangle. I'm trying to find H. So if I were to look at this, and I know the hypotenuse, and I'm trying to find the opposite, I could do a SOHCAHTOA problem. Sine of 35 degrees is opposite H over hypotenuse Y. Opposite over hypotenuse. So Y times the sine of 35 degrees equals H. So this is what you have to do. This expression right here is Y. We're going to take that, pop that in there to y, calculate that, times calculate that, and that is going to give us our perfect answer for h. Nothing has been rounded or chopped until the very end. Okay, finally, calculator time. 20 times the sine of 12. Make sure you close that up, divided by the sine of 23 degrees. Okay, you could hit enter here if you like, or you could just keep going. But now we're going to multiply answer times the sine of 35. Okay, at this point we will round, and the tower is 6.10 feet tall. Oh, I guess I wasn't standing on a tower. I was probably just standing on, I don't know, a little ladder or a tall desk. Okay. Two trains leave a station on different tracks. Okay, so we have two trains leaving. They're going in different directions. The tracks make a 112-degree angle. So let's pretend this is the station. And one set of train tracks goes this way, one set of train tracks goes that way. And the angle is 112 degrees. Okay. The first train travels at a speed of 90 kilometers per hour. And the second train, a little slower, 55 kilometers per hour. So when you're making these, let's see, how far apart are they? So this distance right here, the distance that they are, okay, since this is a distance, I'm going to need to make sure that the rest of my picture, the rest of my units are all in terms of distance. So I can't put the speeds on these sides. I need to do a distance. Luckily, I remember a distance formula, and distance equals rate times time. So we're going to need to do that for both of these. Okay, let's see. I'm going to call this train number 1. Train number 1 travels at 90 kilometers per hour. So the rate is 90. And the time is 2 hours and 45 minutes. So that's well, it's not 0.45, is it, on a clock? If you go 45 minutes is 3/4. 3/4 is 0.75. And so please find the distance that this first train travels. 247.5 kilometers. All right, we're going to have to do it over here again. Distance equals rate. The speed of that train is 55. His time is also 2 hours and 45 minutes. That's 2.75. So his distance is 151.25 kilometers. Okay, since we have kilometers, I can now find the distance in terms of kilometers. Okay, I'm going to call this x. All right, how are we going to find this? It's not a right triangle, so I'm going to have to do either law of sines or law of cosines. And when you have a side angle side, I'm going to do, I don't think law of sines is going to work. We're going to have to do law of cosines here. Okay, and the angle determines how you start. We're going to start off with x squared equals, all right, give me a side. 151.25 squared plus the other one, 247.5 squared. Now that's too much. We have to subtract 2 and then each of them. 151.25 times 247.5 times the cosine of 112 degrees. Okay. This is all I need to see on your test. Type in all this stuff real nice. Don't forget to square root. X approximately. What's the distance between the trains? $334.93 kilometers. Okay, let's take a look at a couple more word problems. This is why we're doing these formulas for real-life situations. Except this is a little weird because I've never seen a room in the shape of a triangle. But this is a weird room, and it is. And it might be a closet. The sides are 7 yards, 8 yards, and 12 yards. Okay, so it's clearly not a right triangle. Carpeting costs $14.50 a square yard. Oh, and of course, under the carpeting, did you know you have to buy padding, which costs $5.25 a square yard? So that's how they get you. The cost is actually, what's $14.50 plus $5.25? It's actually $19.75 per yard squared. Okay, so we have to figure out how much area is this room? How much area, because that's the cost. Okay, how much will it cost to carpet with the carpet and the pad? And you assume there's no waste, so we're just going to find the exact amount for this triangle. How are we going to find the area of a triangle? You don't want to find the angle or the sides. We're not doing law of sines or cosines. This is area. This is area. And I think we're going to have to do Heron's formula. The first thing we're going to do is figure out S, the semi-perimeter, half of the sum of all the sides. So what is the semi-perimeter for this triangle? 13.5. Okay, Heron, here we go. The area equals big square root. First thing you do is you put the semi-perimeter down. In the first set of parentheses, semi-perimeter minus 7, semi-perimeter minus 8, semi-perimeter minus 12. And the area is approximately 26.91 yards squared. Now we're going to go ahead and figure out the cost. So what we need to do is take that area, and we're going to have to multiply it by that number right there. If you have this number in your calculator from before, you can use that. That's how big the room is, but it's going to cost us $19.75 times that. So the cost is $531.40. Because there's some more decimals here, dot, 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 that I kept in my calculator. So I didn't chop until the very end. Okay, we got one more here. An aircraft is spotted by two people who are 1,000 feet apart. So let's go ahead and label the distance between them here as 1,000 feet. One observer sights the aircraft at an angle of elevation right here of 40 degrees. And the other observer, his angle of elevation is 35 degrees. Okay, find the altitude of the plane. So what they want us to do is find this height right here. Okay, should I mark this as 500, 500? No, not a good idea. A lot of people tend to want to do that because it looks like it's going down the middle. Except these are not equal angles. These are not congruent. It's not half and half. The picture is probably something a little more like this, where one side's a little farther, of course, different angle, and so that wouldn't make sense. So it's not 500, 500. Okay, so that doesn't help us. We're going to have to find something in the meantime. So it doesn't matter, but let's pick a side. I'm going to find this side right here and call it x. Okay, so what I'm going to do is I'm going to make an equation. And I'm going to need to know this top angle up here. I'm using the big triangle. In fact, I'm going to draw a big triangle so it's clear what I'm doing. I'm finding x. I know 40. I know 35. I know 1,000. Let's find the missing angle in that triangle. That's 105 degrees. So now we could do the law of sines. Sine of 105 goes with 1,000 equals, now we're going for x, so let's do sine of 35 degrees goes with x. Okay, let's go ahead and cross multiply here. But again, let's kind of hold off with picking up our calculator until it's time to do some calculating and chopping. We'll divide by sine of 105 on both sides. And so I have, when need be, the value of x. Now we're going to go back to our triangle, and we're going to look at just this little triangle here on the left. This is a little triangle, and I know x, or I could find x, and I'm trying to find h. So if you look at just this half right here, this is a right triangle. I know the hypotenuse, and I'm trying to find the opposite. So let's make a sine equation. SOHCAHTOA. SOHCAHTOA. Sine of 40 degrees is opposite h over x. If you multiply both sides by x, x times the sine of 40 equals h. And I have an expression here for x. So if I take this calculation right here, pop it into the x, take that calculation times by sine of 40, I could tell you that the height of this plane, the altitude, is approximately 381.69 feet. Maybe it's a drone. Have a great day.